This is worksheet 0.5. There is no textbook work on this section. And this section right here is preliminary information and work that we're going to be using later. So the first thing that we want to do, and I'm not going to have time in this video to do all of these, but I will do a couple. But you are required to draw what is called the basic or parent function of these main functions that we're going to be looking at throughout this course. Some of these you'll know how to graph now. Some of them you may not. That's okay. We'll cover it a little bit later if you don't know how to do it. You want to state the domain and range of each of these parent functions because that's what we're going to be doing a lot of in here. So what I'm going to show you is a lot of preliminary stuff, and we are going to cover it again at a later date in this class in different sections. So this is your first preview look of stuff that's coming later. Okay? When we get done with some of these things, I'll show you. I'll do a couple of these things with you in this video, and then you will need to finish the rest as part of your homework. Okay? There is 8 of them, I believe. And just get a piece of graph paper and just put 2 on 1, or you can even use this paper right here. It's up to you. I don't really care too much. But you want to know and be familiar with these parent functions because these are what we use for graphing some functions later on. The next thing that you come to is a bunch of like a journal worksheet or something like that, or a classwork. So, and that's fine. We're going to talk about those. So the classwork is really going to be kind of like extra problems that you can do and work with. You are responsible for the page that says HW or homework. This is the homework section, the stuff you're going to hand in to me. You're only going to hand in the work for this page right here. Any other work that you do for this packet is all on your own for your note purposes and your practice purposes. This is the one you will hand in to me. The chances are very high you'll have to use other paper to show your work because there is not enough room on this packet page to show your work. So please use graphs on graph paper and other work on another piece of paper. So with that being said, let us begin. So we'll do some of the ones that you are familiar with. We'll start off. I'm not going to graph the line. You can do that one on your own. Let's graph this quadratic, this parabola, x squared. What I want from you also is I want your basic table. So what is the basic table? You're literally just going to plug in points into a table and graph this shape. So for this one, and many of these graphs, put the little table down here. You have an X and a Y. You're going to graph about 5 points. And most of these graphs that we're going to be doing, you're going to center it around 0. So when you graph something and you don't know what the graph looks like, you want to graph positive numbers, some negative numbers, and 0. So in this case right here, we're going to start with 0 in the middle. We're going to do 1 and then 2. And then we're going to do -1 and -2. This is your standard 5-point table. Start here, unless there's certain graphs that you'll see that don't. Most of these are going to have this basic 5-point table. You plug these numbers into the equation to get the y value, and then we graph the dots. So -2 squared, +4. -1 squared, +1. Then there's 0, then 1 squared, and 2 squared. So these are the points that are solutions to this equation. We take those numbers and we put dots on our graph in their appropriate spot. 0, 0, 1, 1, 2 goes to 4, and then this side over here, -1, 1, -2, 4. So we can see that we have the classic parabola shape, and we want to draw this parabola out as neatly as we can because this is our reference page. Arrows on the end. So that's the parent function, your x squared. All other x squared graphs are based off of this one right here. This is the parent one. All of the others are related to this one in some fashion. And we will discuss that in more detail later. So, what do we know about domain and range? Again, if you're unfamiliar with domain and range, Don't worry about it right now. We will explore that concept in more detail later on. So the domain is, what values of x can I plug into this equation and get an answer for? For a lot of problems, as you will see, almost every x will work. There are certain conditions where it doesn't, but for this one, the ones that are called parabolas or lines or even polynomials that we will explore later, the domain is pretty much all the real numbers. And there's a couple of ways to write it. For our purposes in here, we can just say all real numbers. And that's good for now. I will change that process a little bit later. But for right now, just have your mind on all real numbers. And now, what is the range? For a range, I recommend highly that you use a graph to help us determine the range. It's easier that way. It's hard to look at an equation and know the range off the top of your head. But from a graphing point of view, it's fairly easy to determine. The question for range is pretty much the same thing. Look where the graph is. Clearly, this graph does not reside in the negative realm down here on the y-axis. In fact, if I start down here at negative infinity and walk up, the graph, I'm not even touching the graph until I get to the origin, which is 0, 0. Then I touch the graph. That is the first y value for this graph, is at 0, 0. And then it's every y value after that. So to express that in a way that we can all of us understand, we would write all the real numbers, comma, the y values are greater than or equal to 0. And so we can write it in that fashion. Again, I will show you interval notation in a later date. This is what I'm looking for right here. And I want you to do the graph, the table, and the domain and range for each of these graphs that represent parent functions. So let's do another one. Maybe we'll do 1, 2, I don't know, we'll see. We can do x to the third. I'll save that one. Turn the page, we'll do one of these over here. Let's look at this, we'll do the square root one. The square root is different. It's one of the ones that are different than all the other ones on this page. For this one, we still want to do about 5 points or so. But for square roots, as we've determined and we know, you cannot take in the real world, you cannot take the square root of a negative value. So I already know that there are no negative values that I can plug in for x. So this one actually has a starting point. Most of the tables on the other ones, I call it the center point is 0. Here is the starting point. This graph starts at 0. And then I can plug in any numbers I want after that. But since I have to take the square root of it, it's better for us to find the perfect squares so I can take the square root of the perfect squares. So 0, I can do the square root of 1. I can take the square root of 4 and 9 and 16. And so that's how this one works. And then you make this table with 5 points in it, but you can see I don't have it out here to graph all of them. And that's fine. I don't need to extend my graph. I just need to draw what I have. I have the 5 points. I know what does happen, but I can only graph the 0, 0, the 1, 1, and 4, 2. So graph the ones you have and aim for the next number. So I have a starting point here, and it goes off in one direction, like that. The domain, all the real numbers, x is greater than or equal to 0. Because x, on the x-axis, the graph starts at 0 and goes to the right, the positive side. The range, all the real numbers. The y's start at 0 and go up from there. Even though it doesn't look like it crosses 5, eventually it will. If I go out far enough, I'll get to 5. So all the y's are greater than or equal to 0 also. So you try and graph some of these other ones. If you're unsure, we can discuss it later, and you can bring it to my attention, and I'll help you graph any of the ones that you are unable to graph from this point on. You can also use a graphing utility, your Desmos graphing utility if you have that, and you can help make the table. Okay, start to center the graphs at 0, try positive and negatives, and see if you can't draw the graph on your own. If you need help with the domain and range, I will be glad to help you with that too, if you ask me the next time we meet. So, parent functions. It goes on over here. Now this one, I'll show you this one at a later date. This one is called the greatest integer function. The greatest integer function. And it's a unique kind of a graph, and I will discuss that with you at a later date, not right now. We don't use this one very often, but I did want to bring it to your attention. Okay. The next thing I want to talk about in here is we need to learn how to talk and discuss things about called restricted domains. So we know every function has a domain, and every one of those is what values of x can I plug in that work. So the domain is all the things that can work, all the x values that work. And so sometimes we need to do what's called a restricted domain. That means if I graph this equation right here, this equation, 2x plus 5, is a line. Its domain is all the real numbers. Every single number works in here. But for some reason, I might want to just restrict that. I don't want to see every single numbers on this graph. I want to see only specific parts of this graph. When I do that, that's called a restricted domain. In the real world, you have restricted domains all the time. Okay? And so you need to be able to see what these graphs look like in a certain limited fashion. So here's an example. Graph this function on that domain. That means that's restricted. The normal domain is all real numbers. This means I only want to graph between 0 and 4. And notice that 0 and 4 are included. If you do not know those symbols, these symbols right here, in a graph, you're going to put a dot. It means the endpoint is included. If I have these other symbols, just the strictly less than or greater than, you will use a circle for that point, and it means the endpoint is not included. So both of these endpoints would be a boundary. Just this boundary would be included, and this boundary would not be. So I just explained what that meant. Identify the domain and range. Okay. Well, let's graph this thing, and then it'll help us with the domain and range that way. The domain is easy. I told it to you. That is the domain. I told you that's the domain, so that's the domain. The range, we can use the graph to help us out. So to graph this on this domain, you're going to make a table. If you know what the shape looks like, you don't need as many points as you might think. Since I know this is a line, okay, I only really need 2 points to graph it. But you should always graph 3 points for a line. 2 points to draw the line, and the third one to check it. Because if you make a mistake on one of the points, your line will be wrong. If you do 3 points and one is off, you'll know. Okay? This way you can make sure that your answer is going to be right. So what number should I do? Well, the domain tells you what numbers to do. If the low boundary is 0, make sure you plug in 0. If the high point of the boundary is 4, make sure you plug in 4. There's your 2 points to draw the line. Pick any third point you want So pick any integer that you want or whatever number you want between 0 and 4. It doesn't matter which one you pick, any one that you want. I'm going to go right in the middle. I'm going to take 2. You can pick any point that you wanted. Take these 3 numbers, you plug it into this, and you give me the y value that goes with it. If you're not familiar with function notation, here's what it would kind of look like if you wrote it out. You don't have to. You can just plug in the numbers and get answers. It's fine with me. But to plug in a number into a function notation, you're saying f at 0 is 2 times 0 plus 5. 2 times 0 is 0, so this is a 5. This is a 5. Now, I don't require you to do that. I'm just showing you this is how you can do it. So if you have more complicated ones or things that you're doing in other situations where you do need to write it out in proper notation, this is what it would look like. So 4 plus 5, 9. And if I plug in 4, 2 times 4 is 8. 8 plus 5 is 13. These are the 3 dots we're going to do. At 0, it is a solid dot because the endpoint is included. This is when you start looking at that. So here's 1, 2, 3, 4. And now I got to get to 13. I don't have 13 boxes here. So I'm going to have to scale the y-axis so that I can see all of these, this point. In a restricted domain, you have to graph what I ask you to graph. So if I go by 2s, am I going to have enough? 2, 4, 6, 8, 10, 12, 14. Yes. So let's go by 2s. That's -2, -4. So graph what we have. 0, 5. That's right about here. And it has to be a dot. Put a dot. You do 2, 9. And 4, 13. And again, at the 4, it is a dot. If it was a circle, I would have put a circle there. So you take your straight edge, because this is a line. Draw the line part between the dots. That is the graph. You need to label the endpoints. This point is 4, 13. This endpoint is 0, 5. And you must always label the endpoints in a restricted graph. For me, this is how you graph on a restricted domain. So again, what's required when you graph for me? Label endpoints. Make sure you scale your axes so that I can see your scale. You should make the table. That should be required right there. Let's go to the next one that I have over here. Oops. Now we have this one. So we want to graph this. And notice I say confirm your graph using a graphing calculator. Well, you can actually use a graphing calculator to assist you. I don't have a problem with that. These are pretty simple. You shouldn't have to worry too much. You shouldn't need it. But if you do need it, go ahead. I'm okay with it. The restriction is what? I want it on x greater than 0. Notice this time 0 is not included. That means when I draw this graph, when I make my table for x and then g of x, the first number I'm going to pick is 0. I am not going to plug in any negative values because the x's can only be greater than 0. I'm going to put 0 in here so that I can establish where my boundary is. So you need the 0 to know where the boundary point is. You're going to draw it with a circle, but you still need to know where it is. Then what numbers do I do next? Just do the next couple. Maybe need to go out to 4 also. I don't know. Now, if you have a graphing utility, you can actually use a calculator to assist you. I'm not sure how Desmos works on this one, but on my calculator, I'm going to show you a little technique right now. For those who are not familiar with my calculator, so just turn it on, push the on button, push it twice so you get to the screen if you need to. Once you're on the screen, you want to open a new document just like it says right here. So you type in the number 1 or you hit select. And the thing pops up and says, do you want to save? The answer is always no. It's going to ask you what kind of document do you want to open. So do you want to do a calculator work or do you want to do graphing work or something else? Since I want to graph, I will select the graph. My function line will open up and all you have to do is just graph the function right there that you see. Okay? Be careful that you type it in as you see it. So this is the negative button right here. Don't use subtraction for negative. You get a syntax error. So we have a negative x squared. You can't see my screen because of the glare. Sorry. Then plus 4x, and then plus 4. So I'll just kind of show you that. Kind of see it that way. And then you hit enter, and it will draw the graph for me. So I can see what the graph is supposed to look like when I get done. Okay? Now, why do all this? I want to be able to fill in this table to get those points. Sometimes it's hard to see them on here. There is a feature on this calculator that will do this for you. I can find any point I want. You see the button that says menu right here. This is your go-to button. Almost everything we do on here in the calculator, especially in the graphing realm, is in that button menu. You push the menu button, and you'll see all the things that you can go to next. Find the one that says trace. If I select trace, it's asking me, I'm going to tell it to trace the graph. I get this. I'm not sure what you guys get. You might, because you have a slightly different calculator, but just trace the graph, number 1. Now, what happened here is that cursor popped up right there. And then down here, you're going to see the point that it's on. And you'll see that it's on 0, 4. It almost always defaults to the y-intercept. So I know that 0, the answer is 4. So at 0, I get a 4. Now I want to go to another number. Well, you're in trace mode. If I want to know what happens at once, don't use the arrows. Just type the number 1. Type 1 and enter. And you will notice that that point down there changed. And the cursor changed. It goes and highlights where 1 is on the graph, and it tells you the point there. So this is 1 goes to 7. Let's do 2. If I type 2 and hit enter, 2 goes to 8. Then it shows you where it's at. I go to 3, back to 7. I can do 4, back to 4. Now, I want to be able to draw this thing. See, I have the x-axis here. It's already set the scale for me. So I need to get past the x-axis. Keep on adding to your table so you get the graph that you can draw. Okay? You're trying to be as accurate as possible. So if you need to add more points in your table. It doesn't take long because you're not doing it by hand. Just hit 5 and enter. That's -1. And do 6 and enter. That's -8. And so now at 6, you can see I'm beyond my scale. -8 would be down here somewhere. Okay? So I have enough to draw this. You can, but we're only drawing from 0 above, right? Once I have this, 0, 4, that is a circle. Because remember, 0 is not included. The rest are included, so the rest of them put a dot. 1 goes to 7, 2 goes to 8, 3 back to 7, 4 is 4, 5 is -1, and 6 will be -8 down here. So draw the parabola we saw in our graph. Just like that. Just like that. What point must be labeled? The boundary. And in a polynomial, you label a couple more points. Which one should you label? If you can label that point up there, you should do so. So that is what, 2 and 8? And then just pick another point. It doesn't matter which one. If you don't, that's fine too. I mean, 2 is like the minimum. 3 would be nice. And there you go. Restricted domains. This leads us to this one. Now, we actually have a section later on. We talk about this in more detail. But this is called a piecewise function. And the reason why it's called a piecewise function is because this function, h, is created by 2 pieces of other graphs. If you understand what I just did right here, that's literally what you do here. You just do it twice. You're going to graph that piece on that restricted domain, and then you're going to graph this piece on this restricted domain on the same graph using exactly the same technique. So you're going to have 2 pieces on the graph instead of 1. See, this is just 1 piece. Over here, we're going to have 2 pieces. Remember, they are functions, so they cannot overlap. Let me say that again. When you do piecewise functions, they do not overlap. A third time, when you're graphing piecewise functions, the graphs do not overlap because they're functions. Okay? So the top piece is restricted for negative values. So when x is less than 0. So when I do this top piece over here, I kind of do it this way. I'm going to plug in x. I'm going to plug it into 2x minus 1. You don't have to actually write that function. I do so I don't forget which table is for which. I'm going to do some numbers. I want to do at least, depending on the function it is, 3 to 5 points is what I'm going to graph. Because I only want x is less than 0, I put the 0 out here like a number line. See, I'm thinking like a number line. If this is 0, the numbers below 0 go that way. So here's the 0, and I plug in negative numbers going that way according to the number line. That's what I do. It helps me when I graph over here to see the table and the way I'm going to graph it. It's kind of helpful. Plug that in. So if I plug in 0, I get negative 1. Plug in negative 1. If I plug in negative 2, that's negative 4 minus 1, negative 5. You can see the pattern here because it's a line. Negative 6 minus 1, negative 7. Now, at this point, you can graph what you have. You can also wait and graph both pieces at the same time. That's up to you. If I graph what I have now, then I've already got the first piece in play. This tells me that it has to be a circle here, right? I'm going to put a circle on that dot. At 0, negative 1, I put a circle. Negative 1 to negative 3. Negative 2 to negative 5. Negative 3 is off my picture here, but it's basically right there. Draw your straight edge. Draw that out. From here onward, and an arrow in that direction because it goes on forever. That is the first piece. Now go back and graph the second piece. This piece starts at 0 also and goes upward. So how many do I do? Well, it's the quadratic. I probably want to do at least 4 or 5 points. And we'll know once we see what these numbers become. And notice this time, I went 0 and then bigger. So I'm moving them to the right. So 0 is now over here. And this one is going to get a dot. Notice I'm putting it above so I don't forget which one gets the dot. And then you plug in these numbers and you get the values that go with them. So 0 squared plus 3, then 1. If I plug in 2, I get 4 plus 3 is 7. 9 plus 3 is 12. If I plug in 4, that's 16. Plus 3, 19. So you can see clearly that the 19 is not even on my picture form. So that one's not going to be in there. Once you have the table, 0, 3 gets a dot. 0, 3 gets a dot. Now, if you're thinking, well, there's 2 values at 0, there isn't. This one is included. This one is not. There's only one value at 0, and that is 3. There is no value on this piece at 0. It's just a boundary. Graph the rest of these things and see what happens. Got that right there. 2 goes to 7. 3 goes to 12. And 4 is gone. This is a quadratic, so it's kind of curvy like that one up here. So when you draw it, make sure you have a little curvy action going on. You have to label the endpoint. So that means you label 0, 3. And another point over here would be great. Let's label 2 and 7. This one needs to get labeled here. This is 0, negative 1. And one more point out here, negative 2, negative 5. So label the endpoint and one more point on each piece. And this graph is done. This is what a piecewise graph looks like. Just a bunch of pieces. As we continue here, I showed you evaluating a function briefly already. So what does it look like on a piecewise graph? So normally what I do is I show you, I'll let you work this problem, but because of the video, I will just show you this. What is h of 3? Remember, this is a function. This is function notation. If you plug in a number, you can only get one answer to be a function. I'm telling you it's a function, so you don't get 2 answers. You only get 1. This has 2 pieces to it, but each piece is defined only in a certain way. When the x value I plug in is less than 0, then it goes into this top piece. But when x is greater than or equal to 0, then it goes into the bottom piece, never into both pieces. Your graph will help you illustrate this. Where is negative 3? Right here. Where is the graph? Down here. See it? There's no graph for negative 3 on the top part. That piece is only going in that direction. There is no negative side to it. So there is only one answer to this piece. H of negative 3. The negative 3 gets plugged into only the top piece. And you'll get h of negative 3 to equal negative 7, which is confirmed in our graph over here and in our table. Negative 3 is negative 7. We have it right there. Our graph, negative 3, only has one point associated with it at negative 7. There is no negative 3x in this piece. That is the only answer you can get. So the same thing is illustrated with these other ones. So this 0, even though we have a boundary for 0 here, it's not included. The only 0 exists right here. So what is h of 0? Right there, it's 3. Where's h of 3? There's no 3 up here. There's only right there, and this answer is 12. So that's how you do points in a piecewise function. Make sure you put it into the piece that it's defined for. So that's the video. There are classwork problems we're going to look at together for more practice.